Listen here. We have started with unit number 3rd, that is your concurrency control. In that first point is your process thread synchronization and mutual exclusion. So in that first point is the principles of concurrency. Why we require the concurrency? So that is the principles of concurrency. So we'll go for the first point, that is principles of concurrency. So first one is which one? Interleaving and overlapping. So what is interleaving? Giving some specific time. Means suppose P1, P2 and P3 are executing. So P1 will execute. After that some time P2 will execute. So that is interleaving. Some time is specified. And overlapping, which one? P1, P2 will overlap one another. Some time will be overlap. So that is a interleaving and overlapping. Can be viewed as an example of concurrent processing. Interleaving and overlapping. So if P1 and P2 and P3 are the processes, so giving some time slice or time quantum for each processes, that is called as a interleaving. Means P1 will execute, after then P2 will execute, then P3 will execute. Likewise, interleaving will be carried out. And overlapping is which one? In which P1 execute sometimes and it will overlap by P3, P4. Likewise, it will execute. Both present some problem, same problem. Both present the same problem. So what is the problems in this? We have studied the context switching. So more time overhead is required. We have to save the current status of the current process and then switch to the second. So there are different problems in the interleaving and overlapping. Okay. Then uniprocessor, the relative speed of execution of process cannot be predicted, in which a single processor is used. So we cannot specify the speed of execution of that process, because that process may require IO waiting or IO operation, or it may go for some another resource. So we cannot predict how much time is required for that process for the execution. Depends on the activities of other process. Because in this, what happens in uniprocessor, suppose P1 requires the resource R1 and it is currently executing. After some time, it requires the resource R2, which is held by P2. So it will continuously wait for the R2, get the R2 resource from the P2. So depends on the activity of other process. Depends on the activity of other process. Then the way of OS handles the interrupt. The way of OS handles the interrupt. So how the interrupt will be handled by the operating system. So again, in this also we have to study which are the different methods for handling the interrupts. So sometimes what happens, operating system will handle the interrupts immediately, or it may give some delay for handling that interrupt. So that will depend on the operating system. And last one is a scheduling policies of the operating system. So which type of scheduling? We have studied different types of scheduling algorithms. So which type of scheduling policies, whether it is long term, medium term and short term, that is based on that policies, which algorithm they are using, that will be specified by the OS. So these are somewhat in a uniprocessor. Okay. So what we have to go, we have to study mutual exclusion, how mutual exclusion is carried out in the operating system. Before that, what is mutual exclusion? Only one process should execute in a critical section. No second process should enter the critical section. So what is critical section? A region where multiple processes or a region where a process will enter and allocate the shared resource. That is called as a critical section. So in critical section, only one process should be there at a single time for the execution and handling the or getting the required resource. That is called as a mutual exclusion. Now how to carry out this mutual exclusion, that we have to find. So based on that, principles of concurrency. So in that first principle, which one? Interleaving and overlapping. So there are some problems of interleaving and overlapping. I explained already. Then second point is a uniprocessor, depends on the single processor. So these are some uniprocessor methods. Then what are the difficulties in concurrency? What are the difficulties in concurrency? First one is your sharing of global resource. Now what happens? Global resource means what? These resources are being allocated by multiple processes. So suppose now we get R1, R2 and R3 are the global resource, means anyone can access that resource, and your P1, P2 and P3 are the processes. So how they will share this global resource? Because these resources are required by P1, P2 and P3. At the time of concurrency, you have got the meaning of concurrency. So in concurrency, more than two processes are executing simultaneously. So how they will share this global resource? So that is the first difficulty in concurrency. Second one is a difficult for OS to manage the allocation of resource optimally. Means what happens here? Means each and every process should get the resource. So how optimally or how minimum time will be given for each process for the execution? How minimum resource will be allocated to that process? So that is difficult for operating system. So management of allocation of resource optimally. Then third one is a difficult to locate programming errors as the results are not deterministic and reproducible. So what are types? Suppose now three processes are executing simultaneously. So which process have got the error? So it is difficult to find. So difficult to locate programming errors as results are not deterministic and reproducible. As the results are not reproducible, we cannot find whether these errors are occurring. So these are some difficulties in concurrency. Now I explain what is race condition. Occurs when multiple, for 2 marks they may ask the question race condition. So race condition is what? Which occurs when multiple processes or the threads read and write the data items. Listen here, definition. Occurs when multiple processes, more than one processes or thread read and write the data items. The final results depends on the order of execution. The loser of the race is a process that updates last and will determine the final value of variable. So what happens in race condition? More than two processes will read and write the data items. Now what happens? Suppose P1 will read the data. So what happens here? Read the data. Only reading is there. But after that, P2 writes the data. And P3 again reads the data. So P3 will read the updated data. So here they have given what? The loser of the race is the process that updates the last. Means what? The last process will update the value. It may be the right data. So it will update the value. So who get the last chance? So here is the race condition. Who comes first? They will get the process, or that will get the resource. So that race condition which one? More than two process or threads read the data items, read or write the data items. So in that, who get the first chance and who get the last chance? So last chance will update the data and will determine the final value of variable. So there is called as a loser. Okay. Then based on the operating system concerns, design and management issues raised by the existence of the concurrence based on the operating system, how concurrency is maintained by the OS. So OS must be able to keep track on various processes. So how to maintain the concurrency, or how the concurrency is maintained by the operating system? So OS must be able to keep the track of various processes, which process is executing, which process is not executing, which is ready state, which is in a newly born state. So that OS must keep the track. Then allocate and deallocate resource of each active process. So that is required done by the operating system. So whichever process are active, we have to allocate and deallocate the resource. Now listen, a resource means what? It may be the IO resource, memory resource, file resource. So these are the resources required by the process for the execution. Protect the data and physical resource of each process against interference by the another process. So that is also required. Protect the data and physical resource of each process. It should not interfere with the another process. So that is the function of operating system. Ensure that the process and outputs are independent of the processing speed. What is here? Ensure that the processes and the outputs are independent on a processing speed. Means what happens? It should not affect the output. Whenever the process is executing, if it is slow or fast, it should not affect the output of that system. So always should maintain all this information. Okay. Now we'll go further. We'll study this in the second part. Before that, so resource competition, how the resource will compete, or how the process will compete for the resource. So concurrent processes come into conflict when they are competing for use of same resource. Okay. Each and every process are competing for the same resource. For example, I/O device, memory, processor, time, and clock. So multiple processes are competing to get the resource. In case of competing the process, three control problems may be faced. So which are the problems that may be faced? We have to study this, how to maintain the mutual exclusion. Before that, we should have the knowledge of this. Means what? When multiple processes are competing for the shared resource, what are the problems they will face? So first one is the need for mutual exclusion. Second one is your deadlock, and third one is a starvation. So these are the three main problems. So what is the first one? What is actually mutual exclusion? As per the mutual exclusion definition, only one process should be there in a critical section. Okay, no second process should enter the critical section. So if these two processes enter the critical section, so there will be no mutual exclusion. I got this one. Means suppose in your class, two staffs come for the teaching, OS and DBMS, for example. So what happens here? It will not be, there will be no mutual exclusion. There will be no mutual exclusion. So this is the first problem. Then second one, which one? Deadlock. So deadlock, suppose I have allocated the resource. And second, suppose in simple language, I am teaching the OS lectures. So continuously I am teaching in a TE class. I am not releasing the resource. So second, third B class is going on. And I want to go to the B class. And B class is carried out, some lecture is there. He is not releasing that B class. So what happens here? Both are not executing. Means it will be the deadlock state. No process is executing. So that will be the deadlock state. And third one is a starvation. You got the definition of starvation last lecture only. Starvation means what happens? The process, one process is executing. Second process is also executing. But third process do not get the processor or any resource for execution. Again, first, second. So P3 will be in a starvation state. It will not getting the processor for execution. So this problem will occur. Now what is mutual exclusion?